Hello friends, this video on equilibrium part 33 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Now we'll take polybasic acid and polybasic acidic base. So what are these polybasic acid and polyacidic base? So if you see something like H2SO4, I'll tell you, it has more than one protons. So acids which have more than one ionizable protons per molecule are called polybasic acid. Example, in this case H2SO4 will first give you H plus and HSO4 minus ion, and this HSO4 minus ion will again give H plus and SO4 minus 2 minus ion, right? So in both case K will be different. First will be K1 and then it will be K2. This is general example. H2X give you H plus and HX minus ion. The K, this value, that is H plus into HX minus by H2X. Again this HX minus from here will be in equilibrium with H plus and X minus 2 minus. So I'll get a different K for this. So I get two Ks, K1 and K2, right? So the approach is different. In polybasic acids or polyprotic acids, I get two ionizable proteins. So I get two different values of K, K1 and K2. That's the only difference here, right? And K1 and K2 are called first and second ionization constant. There are two constants now. So if it is 3, for example, I think S3PO4, it has 3 ionizable proton. So it will have K1, K2, K3. It's first, second and third ionization constant for this acid. There's a table for this if you see. For example, if you see the phosphoric acid, if you see, there are 3 K, K1, K2 and K3. If you see sulfuric acid, K1, K2. Oxalic acid, K1, K2. So it can have K1, K2 or K1, K2, K3, depending on the number of ionizable proton it has. And please note, if you see, the higher order ionization constants are smaller and the lower order ionization constants are bigger. So if you see, these values will be more. Actually, less. Why? If you see, the next ionization will not happen so easily. Example, H2SO4 gives H plus and SO4 minus, and HSO4 minus will give you H plus and SO4. So if you see, this will easily give one H plus, but next H plus is difficult to get, right? Because already it has lost one H plus. So this reaction will happen less in the forward reaction, and thus the Ka2 value, this is A1 and this is A2. The Ka2 value will be lesser than Ka1 because this reaction will happen more in the forward reaction. This will happen less in the forward reaction. So the question says the first ionization constant of H2S is 9.1 10 to the power minus 8. So I have something called H2S. It gives H plus and HS minus. And for this Ka1 is 9.1 10 to the power minus 8. Right? Second ionization constant for this is 1.2 10 to the power minus 30. You need to find the concentration of S2 minus and also HS minus. So let's take this reaction first. H2S will be in equilibrium with H plus and HS minus. T is equal to 0, it was 0.1 m solution, 0.1 m, 0 and 0. T is equal to equilibrium, this becomes 0.1 minus x, this becomes x, this becomes x. Ka1 is what? X square by 0.1 minus x, and that value is given 9.1 into 10 to the power minus 8. You solve it, you get x is equal to 9.54 10 to the power minus 5. Thus, the concentration of HS minus is nothing but x So concentration of HS minus is 9.54 into 10 to the power minus 5. Done. Now let's talk about the second reaction. The second reaction I have with HS minus gives H plus plus H2 minus. T is equal to 0. What is the value? This value. This becomes 9.54 into 10 to the power minus 5. This is 0 and this is 0. At T is equal to equilibrium, this will be 9.54. This is 9.54. 10 to the power minus 5 minus x, this becomes x and this becomes x. Sorry, this is not x, this is, see at t is equal to 0, it has some values, and that was nothing but H plus ions only, right? That is 9, or let me do it once again. We'll do the whole thing once again. HS minus ion gives the space also H plus plus H2. So T is equal to 0. This was, see, H plus ions also was same value. Correct? You see, H plus and HS minus both have same values. T is equal to 0. HS minus will have what? This guy 9.54 into 10 to the power minus 5m. This is the same thing. 9.54 10 to the power minus 5m, and this will be 0. At T is equal to equilibrium, what will happen? This guy will lose some Ym and this guy will gain some Ym and this guy will become 0 plus y. If you want Ka2, if you just put the value of Ka2 here, Ka2 is what? This guy 9.54 10 to the power minus 5 plus y. This is the concentration of H plus, concentration of S2 minus, that is y, divided by concentration of HS minus, that is 9.54 10 to the power minus 5 minus y. Correct? And this value is what? Given 1.2 into 10 to the power minus 30. Right? This is equal to this value. Right here, 1.2 into 10 to the power minus 30. So if you solve this, equation, you get y as 1.2 into 10 to the power minus 13 itself. See, because this guy and this guy is almost same, right? This guy is, you can cancel it because y is very small, so this guy will be equal to 9.5 10 to the power minus 5 only, and this guy will also become 9.5. Cancel, so y it come out to be 1.2 10 to the power minus 13. And that is my S2 minus ion concentration. And that is my answer. Let's take the example. The question says, assuming complete dissociation, we define the pH of the following solution: 0.03 m HCl and 0.05 m NaOH. So it says that I have HCl and it completely dissociates into H plus and Cl. T is equal to 0. My HCl was 3 into 10 to the power minus 3 m. T is equal to, I won't say equilibrium, T is equal to, after some time, infinite you can say, this becomes 0 and I get 3 into 10 to the power minus 3 m H plus ions and 3 into 10 to the power minus 3 m Cl minus ion. So pH is what? Minus log of H plus ion concentration. So what is H plus ion concentration? 3 into 10 to the power minus 3. That is nothing but 2.5. Correct. Let's take this guy. NaOH. NaOH will completely dissociate into Na plus and OH minus ions. So let's suppose T is equal to 0. It was 5 into 10 to the power minus 3 m. This was 0. This was 0. T is equal to infinite. After some time, this becomes 0. This becomes 5 into 10 to the power minus 3 m. This also becomes 5 into 10 to the power minus 3. Right? So my OH minus concentration is what? 5 into 10 to the power minus 3 m. So H plus is what? Will be 10 to the power minus 14 by OH minus. Correct? Because you know that OH minus concentration into H plus concentration is going to KW, that is 10 to the power minus 14. So with this, you get H plus as nothing but 10 to the power minus 14 by 5 into 10 to the power minus 3. You solve it, you get 2 into 10 to the power minus 12. So pH will be what? Minus log of H plus concentration. So what is H plus here? Minus log of 2 into 10 to the power minus 12. You solve it, you get 11.00. And that is the answer. So in this case, when you dissociate acid, you directly get the concentration of H plus, but in case of base, you get the concentration of OH minus first, and then you have to find the concentration of H plus, because to find pH, you want the concentration of H plus. Let's take one example. You have to find the pH of this solution. 2 gram of TiOH dissolves in water to give 2 liters of solution. So I have TiOH plus water, some water, 2 liters, gives you Ti plus and OH minus. Sorry, it's TL, yeah, TL. TL plus and OH minus. So we have 2 grams. And I have to find T is equal to 0. What is the concentration of this? Right? And assuming 100% dissociation. So in the past example, the molar concentration of HCl and NaOH is given, but here the gram is given. So first you have to find the molarity of TiOH. TiOH is nothing but 2 by, since it is 2 gram, 2 by 221, because 221 is a molecular mass, into 1 by 2 liters, right? Moles per liter. That is nothing but 4.52 into 10 to the power minus 3 moles per liter, or m. This is the molarity of TiOH, right? So if you take the same exact equation, so at T is equal to 0, this will be TLOH will be 4.2 into 10 to the power minus 3. This will be 0 and this will be 0. At T is equal to infinite, this will become 0 and this will become 4.52 10 to the power minus 3, and this will also become 4.52 10 to the power minus 3. So my H plus OH minus concentration is what? This guy. That is 4.252 into the power minus 3. So I have to find H plus and concentration because I have to find pH. So H plus will be what? 10 to the power minus 14 by OH minus concentration. It's nothing but 10 to the power minus 14 by 4.52 into 10 to the power minus 3. You solve this, you get 2.21 10 to the power minus 12. Right? This is the value you will get. So pH will be what? Minus log of H plus. That is nothing but minus log of this value, 2.21 10 to the power minus 12. You solve this, you get 11.66 kilograms as the pH. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.